here is that today's day 6. We're in the final countdown of class. We have 3 classes this week, 3 classes next week, and then we have our last exam during finals week. Over the Thanksgiving break, I did get some work done. I wrote your 3rd test, and I also wrote an optional last test. So if anyone wants to take, it's sort of like a very short final. It's just an hour test. But if anyone wants to take that and replace a low test score with that, you will be able to do that then. Okay. So before break started, we talked about section 3.2 a little bit. And one thing that I want to do, let me see if it'll go to it. Yes, is in the box folder for this class. There's my hope is that you already caught up on the class video for section 3.1 and also the class video for the first part of section 3.2. And then we did a little bit of recap yesterday before Thanksgiving. Don't remember the day. What I want to do is first off remind you that technically speaking, 3.1 online homework is due tonight by midnight. If anyone wants me to extend it for one more day, I would do that, but somebody needs to ask me to do that. Okay, so if there's anyone on Zoom or anyone in class who wants it extended an extra day, speak now or forever hold your peace. All right, then. I will keep 3.1 online homework due tonight by midnight. Cool. Wow. That's a first, that nobody asked me to extend something. Okay. So what I want us to do now is I want us to continue talking about section 3.2. The other thing that I indicated to you, sorry. The other thing that I indicated to you is that there was that video in the My Open Math that talked about the quadratic formula. My assumption is that you've used the quadratic formula before. Am I correct in that or not correct? If you don't remember it, you got to tell me. Okay, so let me go through this right quick here, okay? So one of the things that we have is like, suppose we have x squared minus 4x minus 4 equals 0, okay? I claim we can't factor that. Again, if we could factor this, we'd want to find 2 numbers whose product is -4, the last number, and whose sum is the middle number. And that just does not exist. Okay, so we wouldn't be able to factor that. One thing that we could do is complete the square in order to solve this. And I'm only going to show you completing the square because I want to show you one other thing. Okay. But in general, when things can't be factored, and actually for the sake of time, I'm going, yeah, we'll do that. I got to show you something so cool. Like I would be a terrible human being if I didn't show it to you. Okay. So if you're solving a quadratic by completing the square, the first thing you have to do is make sure you have a 1 in front of your first term. Okay. The next thing that you do is you move your constant to the other side. So we would add 4 to both sides. Now, this is nothing that I would do in practice. I would just use my quadratic formula. So you move your constant to the other side. And you saw these steps in that video that I made in that first part of 3.2. Might have been a bit, but okay. And then the next step is you complete the square. Okay. In other words, you take half of this middle number. What is half of -4? -2. Always write it to the side. You square it. What do you get when you square -2? Get a +4, right? And then you add that number to both sides. Again, you can't have an equation and add something to one side without adding to the other side. So again, you take half of the middle term. You square that. And then you add to both sides. I think you'll grant me on my right side, we get 8. And the left side, recall, you want to write as some quantity squared. The number that goes here is what you got when you took half of the middle term. That's why I always recommend you write it to the side. You with me this far? And now what you do is you take the square root of both sides. What's the square root of anything squared? Isn't it just itself? You with me there? And the square root of 8, well, you can't take the square root of all of 8, but you can take the square root of part of 8. You can break it up as 4 times 2. So don't you get positive and negative 2 root 2? Square root of 8 is the square root of 4 times 2, which is the square root of 4 times the square root of 2, which is 2 root 2. So to solve for x, we would add this 2 to both sides, and we would get 2 plus or minus 2 root 2. Okay. Now, what I want us to do, and you don't have to write this part down, okay? But this is so cool. What if I wanted to take a general quadratic and set it equal to 0 and solve? Well, we can't assume that we can factor it. So what we're going to need to do is complete the square. Okay, you don't need to write this part down. You will not be asked to do this sort of thing, but I claim it's going to lead us to something so cool. Hey, Alex, Bailey, and Kiki, I hope you're psyched and ready for something really cool. All right. So if we were going to complete the square here, remember I told you I wanted a 1 in front of my squared term. So what I would do is I would divide everybody by a. Okay. And again, you can write this down if you really want, but I'm going to lead you to something really cool. So do you agree if we divide through by a, we're left with x squared, and then we have b over ax and c over a, and 0 divided by a is 0. Remember, the next step with completing the square was to move our constant to the other side. So what I do is subtract c over a. Now, my next step is the completing the square portion of it, okay? Recall, with the completing the square portion, what you do is you take half of the middle number. So you take half of means times b over a. Doesn't that give you b over 2a? Right? Multiply your numerators, multiply your denominators. I always tell you when you take half the middle term to write this number to the side, we want that. Now, what we're supposed to do is square that and then add that to both sides. So I want you to tell me, what do I get when I square this mess? Well, what do I get in my numerator? In my denominator, I get 4a squared, you're right. In my numerator, don't I have b squared? Right? You square your numerator and you square your denominator. You with me there? All right. For once, my left-hand side is easier. Remember, the number that goes here is what you got when you took half the middle term. That's why I always tell you to write it to the side. What do we need over here in order to combine these two guys? Don't you need a common denominator? What's my common denominator going to be? Well, we got 1a here. Here we have 4a squared. Won't it be 4a squared? So how do I write negative c over a with a denominator of 4a squared? What do I need to multiply to get from a to 4a squared? Well, how do I get a 4? Don't I multiply by 4? And then we have 1a, we want 2. So wouldn't I multiply and divide by 4a? All I'm doing is I'm trying to get a common denominator here. You with me? Okay. So this gives me, I've got b squared, I've got 4a squared in my denominator, and then I have minus 4ac. I just bebopped the order of these two. Okay, my next step is to take the square root of both sides. What do I get on my left-hand side? X plus b over 2a. Now on my right-hand side, I claim my numerator I can't do much with. What is the square root of my denominator, though? Well, what's the square root of 4? 2. What's the square root of a squared? 8. Now, in order to solve for x, don't we just move this term over? We subtract b over 2a from both sides. Notice we already have a common denominator, so we don't have to sweat that one again. And what we have is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Does that look familiar? This is your quadratic formula, my friends. So this is the exciting thing to me. So often you're just given your quadratic formula and say, this is how you find your zeros, but you never know where it comes from, okay? So the beautiful thing is we've now just derived our quadratic formula. And the crowd roared. So let's just do one example using our quadratic formula. So again, when I want to find my zeros, I always factor first if I can. If I can't factor, I just jump to my quadratic. When you use your quadratic formula, what I would recommend you do is identify what your A, your B, and your C are. Now notice you need it set equal to 0. You need everybody on one side. So in this particular example, what is my A? 6. What is my B? -4. And what is my C? -1. And now we plug it in. So we have X is -B. If B is -4, what's -B? +4 plus or minus the square root of B squared minus 4 times A, which is 6, times C, which is -1. That whole thing is divided by 2 times A. All right, now we got to clean up the computations. Order of operations, don't forget it. What is -4 quantity squared? 16. And notice a negative times a negative is a positive, so that's +24 over 12. So that gives us 4 plus or minus the square root of 40 over 12. Now we can leave this in exact form and just clean it up and simplify it, or you can get a decimal approximation. Are there questions to hear? Okay, so if we wanted to clean this up a little bit, okay, we need to do some side work. Square root of 40, can't take the square root of all of 40, but can't we write that as 4 times 10? So that would be 4 plus or minus, well, what's the square root of 4? 2 root 10 over 12. Furthermore, 2 goes into each of these numbers. Once something's under a radical, it's not touchable. Okay, but I can factor a 2 out of my numerator and then simplify that. So one solution would be 2 plus the square root of 10 over 6. And if you put that in your calculator, you're going to get approximately 0.86. And the other one is 2 minus the square root of 10 over 6, which is about -0.19. All right. So what I want to say are a few things. We have the general form for our quadratic. Okay. And I'm just summarizing now everything that we've done in this section, putting it together. Okay. The nice thing about this form is that you can read off your vertical intercept, right? Isn't our y-intercept 0, c? And when we were in this form, we could find our vertex. You may or may not recall that the x value for your vertex is -b over 2a. Couple other things that we saw here is that when a is positive, doesn't this open up? In other words, the long run behavior is that both arms are up. And if a is negative, we know that this opens down. And the other cool thing about knowing that it opens up is we know that our vertex is the minimum, right? Your vertex is right down here. Whereas if we have a parabola that opens down, our vertex is a maximum. We also saw that we had a vertex form of writing out our quadratics. And what we saw is that our vertex is HK. And finally, if it could be factored, our factored form looks like this. And then P and Q are the zeros. Thank you. And again, if you have a quadratic and you want to find the zeros, you set it equal to 0. If you can factor it, life is cool. If you can't factor it, use your quadratic formula. So what I want us to do now is practice some examples, okay? I claim we've gone through the bulk, but now we got to put it together, okay? So what if I asked you to find the equation of the quadratic if the vertex is 3, 3, and it passes through, say, 2, 2. Now we have any one of these 3 forms here, but notice the form that I'm going to find the equation in depends upon what I'm given. There's almost no situation where you would do this form. Okay, so what I'm going to tell you is if you're given your vertex, I would recommend you find your equation using the vertex form. If you're given your zeros, I recommend you find it using the factored form. Okay, so you all agree we're given our vertex. So therefore, this is the form that I'm going to put it in. We're given that our H is 3 and our K is 3. So do you agree we can plug that in to get X minus 3 squared and then plus 3? The only thing we need to do now is figure out what this value of A is. Okay, you've got to be given another ordered pair that it goes through. Well, in fact, we are. Aren't we given that when X is 2, Y is also 2? So let's plug that in. Well, 2 minus 3 is -1. And what's -1 squared? Isn't it +1? Yeah, so aren't we just left with A plus 3 over here? Can I solve for A? Subtract 3. So we get A is -1. So the equation of this parabola is, I put in A to be -1. Notice I don't usually put -1 or +1. I just put negative. Does this open up or open down? It opens down. Good job. We know that because our leading coefficient is negative. You with me there? All right. What if I give you the equation now? And what I want us to find is our vertex, our y-intercept, and any x-intercepts. Because this is not in vertex form, I would use the shortcut method for finding the vertex. Remember, the x value for your vertex is negative b over 2a. Okay, well, if b is 12, what's negative b? Negative 12 over 2 times a, which is 4. So do you agree I get negative 12 over 8 or negative 3/2? And if you want to write it as a decimal, go for it. Am I done finding my vertex? Remember, with each of these, they're ordered pairs. I have the x value for my vertex. What do I now need to do? I need to find my function value. So what I need to do is say, okay, when x is negative 3/2, what's my function value? All right. So we got 4. Well, negative 3/2 squared is, I claim, 9/4. Here, 2 goes into itself once, into 12, 6 times. So I get minus 18 minus 12. And the beautiful thing is these 4's cancel. So I got my vertex. What's my y-intercept? Well, how do you find your y-intercept?
Set x to 0.
Yep, and if you set x equal to 0, doesn't negative 12 come right out? Remember, that's the most beautiful thing about being in this form is you can read off your y-intercept. Right, you agree if you find f of 0, you're going to get negative 12? You ready?
Yeah.
Last part, x-intercepts. Find your x-intercepts. You take your function and you set it equal to 0. Well, we might as well see if we can factor this first, right? I mean, wishful thinking, perhaps. You may or may not recall the first thing that you're supposed to do whenever you factor, but it's to pull out anything in common. And do you agree that there's a 4 in each of these terms here? So we can totally yank that out, and we're going to get x squared plus 3x minus 3. Now, it's a rather unfortunate turn of events, but I claim you can't factor this middle thing. Okay? One thing that I would say is we can essentially divide both sides by 4 because we have an equation. So really what we have to solve is this guy. Right? You see if I divide by 4 here, it cancels, and 0 divided by 4 is 0. So guess what we get to use? Quadratic formula. What's my A and my B and my C?
A is 1.
Good.
B is
And C is, you got it. And have it in front of you if you don't remember it. Notice B is 3, so we have X is negative B, so negative 3 plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So we have negative 3 plus or minus what? 9 plus 12 over 2. And we could certainly get a decimal approximation, but the lazy side of me says, well, one solution is negative 3 plus the square root of 21, and that whole thing divided by 2. And the other solution is negative 3 minus the square root of 21 divided by 2. Woo! So what I want to do now is I'm going to share my screen. Okay. I want to go through a couple of examples here. So this first one, what we want to do is write an equation using any form for this quadratic. Okay. When you are given a graph to find an equation, you do the same thing as kind of what we did at the start. You ask yourself, am I given my vertex or am I given my zeros? Because if I'm given my vertex, I'm going to use my vertex form. If I'm given my zeros, I'm going to use my factored form. Okay. And just for the sake of it, let's use our vertex form here. Okay. What is my vertex here?
1.
1, 4. Now, in addition to your vertex, you need one other point that this passes through. Okay. If possible, I always try to pick something with a 0. And do you agree that it passes through 0, 3? In this one, do we expect our A to be positive or negative? And how do you know? Negative, because it opens down. All right. So I'm going to stop sharing my screen for just a moment because we have the information that we need to find the equation. I'm putting it in my vertex form. So x minus 1 squared plus 4. Are there questions how I plugged in my vertex? And now how do we find the value of A? Good job. We're going to enter in 0, 3. Well, 0 minus 1 is -1. -1 squared is 1. So I'm left with a plus 4 equals 3. Move my 4 over. So we got -1. And there's my equation. Isn't that cute? You with me? Okay. Now, I'm going to share my screen again. But now we're going to do this guy, number 4. Very similar, but notice the information that we're given is different. Here, what are we given? Aren't we given our zeros, our x-intercepts? And that it passes through this other point. Because you're given your zeros, I'm going to stop sharing my screen. I am going to use my factored form. So I have an A, which I'll always use this extra ordered pair to find. Well, one of them is x minus a -3, and the other one is x minus 1. So do you agree thus far? We have a times x plus 3 times x minus 1. I got to find a. How do I do it? Plug in my ordered pair. So I have -3 is a times 0 plus 3 times 0 minus 1. Oh, this is sweet. Well, I claim you're going to get -3 is -3a, so we just get a to be 1 here. You could write a 1 in front. I tend not to do such things. Isn't this cute? And I think you'll grant me that this totally jives with our graph opening up. Okay. Now I want us to do number 7. So I want to give you a moment to read number 7. So what we have is that the height is y in feet of a ball thrown by a child who happens to be my height. And x is the horizontal distance in feet from the point at which the ball is thrown. So essentially what we have is y is -1/12 x squared plus 4x plus 5. And the first question we're asked is, how high is the ball when it leaves the child's hand? Do you agree we want to find our y value? How high is the ball? Well, when you're given the initial value, isn't that x equals 0? So can you tell me how high the ball is when it leaves the child's hand? 5 feet. Now what we want to do is find the maximum height of the ball. So find maximum height. And then how far it hits the ground. All right, so the next thing that we want to do is we want to find the maximum height of the ball. I'm going to stop sharing my screen. How do we find the maximum height of this?
Set Y to 0.
That would be when it hits the ground. Well, what can you tell me about this parabola? Does it open up or down? It opens down. How do you know? Because this is negative. When a parabola opens down, where's the maximum at? The vertex. So in order to find the maximum height, what we need to do is find the vertex. Now, notice we want to find the maximum height. X represents our horizontal distance. So in particular, we want to find the Y value for our vertex. Well, I would not bother completing the square to get it into vertex form. I would use my shortcut. Well, B is 4, so negative B is negative 4 over 2 times A, which is negative 1/12. So I have negative 4 over what? Negative 1/6, which is a positive 24. What do I do with this value of 24? Well, I got my X value. How do I find my corresponding Y value?
Would you enter 24 in the equation?
You got it, my friend. What we would do is compute F of 24. So I have negative 1/12 times 24 squared plus 4 times 24 plus 5. And I love my calculator. So I'm going to hit 24 squared. And then I'm going to divide that by a negative 12. And then I'm going to add plus 4 times 24 and then plus 5. So we get 53. So the maximum height it goes is 53 feet. This is the importance with word problems of knowing your vertex is the max or the min. Finally, how far does it go? In other words, find the X value when it hits the ground. What is your Y value when it hits the ground? 0. It's the height, right? The height is 0 when it hits the ground. So this is where we take this thing and set it equal to 0. Do you all see why we set it equal to 0? Now this is just totally yuck. But we're going to do the quadratic formula. X is negative B. Well, if B is 4, negative B is negative 4. Plus or minus the square root of B squared minus 4 times A times C. And that whole thing is over 2A. Now, I know that this looks disgusting, but again, we have technology. We can use technology. So what I would do is I'd compute what's underneath my radical. So I have 4 squared minus 4 times 5 times negative 1/12. So we're going to get negative 4 plus or minus the square root of 17.6 repeating. And we could say that's over negative 1/6. Do you agree we need to find what this radical is? So what I'm going to do is take the square root of it. So I get negative 4 plus or minus 4.2 over negative 1/6. Now I'm going to take this to completion, not because I really care what the answer is, but because there's something important we're going to get to. So one solution is negative 4 plus 4.2 over negative 1/6. And the other solution is negative 4 minus 4.2 over negative 1/6. Here, you're going to get negative 1.22. So negative 4 minus 4.2 divided by negative 1/6. And here we're going to get 49.2. Are both of these our correct answers? Whenever you're doing a word problem, you got to go back to the context of the problem. Remember, X is your horizontal distance. Can you have a negative horizontal distance? No. Just like if X represented our time, you can't have a negative time. So there's only one solution here. Yes.
How did you get from 17.6 repeating to 14.2?
To 4.2?
Yeah.
I took the square root.
Right.
I took square root of 17.66666. There it is. Yeah, calculator, my friend. All right. So, well, let me just ask you this because we have like 2 minutes. What are my zeros of this guy? Five is one of them for sure. Notice here, I'll just annotate on my screen here. Notice we have the product of two things equal to 0. Doesn't that tell us that either the first one is 0 or the second one is 0? In other words, the first one is 0 means X equals 0. And the second one is 0 means X minus 5 is 0. So what are my two zeros here? 0 and 5. Make sense? Ross, you good?
Yeah.
Okay, awesome. All right, well, that completes section 3.1. So the last thing that I'm going to do in front of your eyes is to set the due date for 3.2 to be due a week from today. Remember, 3.1 is due tonight by midnight. No one asked me to extend it, so. There we go. Cool. Thanks. We'll start 3.3 on Wednesday. I hope you all have a great day.
You too, thanks.
Thank you.